Good morning everyone, welcome to your Wednesday's geography lesson. Now we are continuing with our topic of natural disasters this term, but we're moving away from earthquakes, and for the next few weeks we are going to focus on volcanoes, which fits in very nicely with our English. So we're going to have a look at our question for learning of how are volcanoes formed. Now we might have some ideas already, but we're just going to go over this in case we're not sure or they'll maybe have some more information for you. So let's first of all remind ourselves, who can remember what is under our feet? Who thinks they could name the 4 different parts of the earth? Pause the video for me and see if you can remember them. So the outside layer that goes around the outside, just like you have on bread, is called the crust. The next layer, which is slightly warmer, it's very, very warm, but it's not as hot as the inside, is our mantle. The next bit, which is our yellowy bit, is the outer core, and then the inside, which is our hottest part, is the inner core. Now this will help us to work out how volcanoes are formed. I'll come on to that in just a second. We've also had a look at tectonic plates before. So these are not like dinner plates you have under you. They are how the earth has been broken up naturally throughout the years. Now, tectonic plates are the outside of the plates where the line is. That's a really important part in our volcanoes, understanding how they are formed. But the whole crust is covered in these tectonic plates. Now these plates, we've also done this exercise before, where we've had a look at how the plates move. So the plates can move rubbing past each other, they can push in towards each other, and they can move away from each other. So when plates rub against each other, that's when we get our earthquakes. When plates move towards each other, that's when we get our mountains and our volcanoes. And when they move away from each other, that's when gaps are formed. That can also happen in earthquakes. So what have tectonic plates got to do with volcanoes? Well, this valley here is over 9,000 years old, and each year it gets about 7 millimetres, which is just smaller than a centimetre. It gets bigger by that each year because the plates are moving apart. Now the rock valley floor was created by cooled lava. So lava came out of the magma centre of the earth, and then it cooled and it created an almost floor. Now the valleys surrounding volcanoes has been formed because the plates are moving apart, and that's a really important part of volcanoes. So here is a map of the world. I'm not even going to try and pronounce this place, but this is a volcano in Iceland, and that's just here on the map. Now this erupted in 2010, so before you guys were born, but I remember this happening, and it caused huge devastation, and planes couldn't fly over Iceland because of all of the gas and ash cloud and stuff that was coming out of it. Now if we have a look at where Iceland is here, on our map, the tectonic plate goes all the way through Iceland. And that is where one of the volcanoes is. And they have to be on that tectonic plate for the opportunity to the plates to move apart, for the lava to come up through the crust and then get stored in the magma chamber. Now I'm going to show you a video of this eruption that happened 11 years ago now. So this is from the time, because it was 11 years ago, so we were able to capture some of it on camera. But this is what is happening to the volcano, and the huge amounts of ash cloud that is coming out of it. So I'm sure, like me, that you could watch that for a really, really long time. And so don't worry, I will put the YouTube link on the assignment as well if you would like to have a look at it some more. But that gives you a kind of basic idea of what a volcanic eruption actually looks like and how we can see all the parts and the ash cloud coming out. So how is a volcano made? Well, this is what it looks like if you chopped a volcano in half and you're able to see inside. What happens initially is pressure builds up inside of the earth, and it starts to, like we did with the plates moving apart, this kind of pressure is underneath the surface, and it's all of that the magma and stuff. It builds up in pressure. It affects the Earth's crust, so sometimes the magma can erupt through it. So this is our crust down here, and the magma inside can sometimes, the pressure can force the crust to break, and then the magma can almost like go inside this chamber. This is where a lot of the pressure is built up. It doesn't happen overnight, it takes a rather long time. Then all of a sudden what happens is once all of this pressure is built up, the magma erupts through the top of the volcano. And then what it does, it kind of like falls down the side. And then what happens is it cools. So you can see all of these layers here are when different volcanic eruptions happened, and the lava cools around the outside and it makes it bigger and bigger. So pressure builds up inside, it blows off the top of either the little mound or the bigger volcano. All of the magma that was stored up inside the volcano comes at the top with lots of other things, ash cloud and rocks and all those things. It then falls down the side of the mountain. Now it is very, very hot when it comes out, and so it's deadly. But by the time it comes out and kind of like falls down the side of the volcano, we're not talking about having the ability to go for, miles and hundreds of kilometers. It cools rather quickly because the temperature of the surface of the earth is much cooler than the magma inside the earth. So once it comes out, it cools, and then we have that volcano that gets bigger and bigger, and each time it can build pressure and it can erupt, and it can keep going like that. So what are all of these parts called? We've talked about some of them, and I've mentioned a few others. So pause the video just for a second. Could you have a go at naming any of those points on the picture? Okay, so this little section down here is called our magma chamber. So it's where the magma is stored. It's the chamber that's inside it. As it moves up, we get to the conduct, which is just like where the next part is. So the chamber and then the smaller part here. At the very top of the whole of the volcano is what we call the vent, and that is where the magma will come up to, and then that's where it will erupt from. Now, when we have the top of the volcano, when all of the lava comes out, this kind of like cloud that is formed is an eruption cloud or the ash cloud that comes out the top. And then this here is pointing at the lava itself. So what your mission today is we would like you to draw your own volcano. So we've given you a word bank that is here, which we would like you to use. Now, some of the words that are on this list we haven't talked about, but you may want to do a little bit more research to find out what the secondary vent is and what the crater is, those things that you might want to have a think about. But the rest of them we have talked about. So we'd like you to do something very similar to this, drawing your own volcano, and then using the labels to label it. And then if you have finished that, what we'd like you to do is to try and write a definition for each of those words. And it says add it to the word bank. We just mean add it to what you've got around the outside of your picture. So hopefully we all know how a volcano is now formed, thinking about that pressure being built up, coming out of the magma chamber and then up to the conduct, coming out of the vent, the cloud that is formed, the lava flowing down, and all the layers of rocks as well that happen. We'd love to see your volcanoes. We can't wait to see what you come up with. Thinking about doing a little bit more research and being able to define those words as well. Please upload it to Teams or Tapestry when you are done. Have a great day, guys, and I will see you very soon. Bye.